Okay, let's have a look at 12. I look at this and I just think, oh yuck. Let's see what happens, shall we? Let's get the gradient function dy dx and see if it's tricky as it looks. 4 comes down to be with the 2 to make minus 8, x cubed, minus, and then it'll be 9, 1 to x squared. And then the 2 comes to be with the 5 to make plus 10x to the 1. Let that equal 0. Now if you look at this row, there's an x common, isn't there? So the first thing to do is take the x that's common outside a bracket, and that will leave 3 terms inside, 1, 2. First term, second term, third term, for the 3 lines. The first term, what times? I'm going to take a minus out as well, just because more terms have minus than plus. So inside we'll have an 8 and an x squared, isn't it? When times by x give you minus 8x cubed. Then I need a plus 9x, agreed? Because that will give you minus 9x squared. And I'm going to need a minus 10, agreed? Because minus times minus is a plus. Then you get 10 times x is 10x. Okay, yeah? So this straight away we know that a turning point is when x is 0, because when that is 0, 0 times anything is 0. So that's taken care of. Now we've got a quadratic. I'm going to find the roots of this quadratic here by writing down the formula. Minus b plus or minus b squared minus 4ac all over 2a. And then what I'm going to do is I'm going to circle the number of x's and put b. I'm going to circle that number there and put c. And I'm going to circle the 8. Hopefully you can see it. And I'm going to write an a. Alright, so I'm just going to get rid of the other lines that I've put there just for the expansion of the brackets. Whoops. Oh, right, okay. I think we can see what's what, can't we? Yeah? So you got an A there. That's a line number, isn't it? So let's get rid of that line number. And that's a line number, I believe. Okay. So you got A, B, and C. Let's put them in and see what we get, shall we? So, B is 9, so wherever you see B you put a 9. So 9 goes there and there. Thankfully it's plus, so I don't need a bracket really. A is 8. Yeah, so wherever you see A I put 8. There and there. Agreed? And then a C is minus 10. So we're going to have a double minus here. So what have we got then? We got minus 9 plus or minus the square root of. Now I'm just going to leave it as is at the moment. 81. And then I've got 4 times 8, 32 times 10, 320. So it's plus 320. Plus 320 all over 2 times 8, wasn't it, which is 16. So x equals then will be minus 9 plus, and that's 401, agreed? 320 plus 81, so it's the square root of 401. So I'll just leave it like that, over 16, or x equals minus 9 minus square root 401 over 16. Let's type them in the calculator then, and see what we get for these turning points. Sorry, I've written in the thicker pen there. Okay, so let's just do the calculator work then. So it's minus 9. So we've got a top number. So I'll put a bracket and I'll put negative 9 minus square root of 401. Okay. And then come outside the square root and close the bracket. And then do divided by 16. Press equals. Get the decimal. Minus 1.81. Minus 1.81. 1.81. Yeah? And then the other one. So let's go back to our calculator. And this time we just toggle back. And instead of minus, that's a minus. So this one, when we come back to it, we'll put that there. We'll swap them around. Let's do a plus. Yeah, minus 9 plus root 401 in a bracket. That's the number on top divided by 16. And that's equal to 0.6, and that's an 8, but the 9 rounds the 8 up to a 9. 0.69, there we go. So this one is 0.69. This one was minus 1.81 because I wrote it in the wrong position. So we need to put the 0.69 in here. 0.69, there we go. That's that done. Okay, good. So we got our turning point. We got our turning point x values. So now we need to trundle those values into the y value. So we work out y then, at this one and this one. So y equals. Now I'm going to use a calculator to do this. And I'm going to write it on the calculator. Alright, 0.69. Remember that. So it's minus 2 times bracket. We've got 0.69, haven't we? Bracket to the power 4. Agreed? Then it's minus 3 times bracket. And then it was 0.69 bracket power cubed, wasn't it? Yeah? Back down to ground level. And then it was plus 5x squared. So it's plus 5 times bracket 0.69 bracket squared. Press equals. And we get, for this one, 0.94. Now instead of 0.69, we got minus 1.81. So I need to go to my calculator. And I'm just going to double check that those entries are right before I go on to the next problem. Minus 2 times something to the 4. Minus 3 times would have been something cubed, wouldn't it? And then plus 5 times the something, yeah? Squared. Yep, everything's right. So what I'm going to do now is go back and just change the 0.69 and then put in its place minus 1.81. So put it in there, right, and then toggle forward. And in here, I need to put it in there, minus 1, won't take long now. And then go forward again. And then we just delete this. Oops, I needed the bracket, I delete the bracket. Minus 1.81. Bit painstaking, wasn't it? And press equals now, because we've done it in all 3 spots. 12.70. Yeah, 12.70. So back to our calculator then, back to our sheet, 12.70. Alright, there we are then, there's our turning points. There was one other turning point we mentioned at the outset, was when x is 0. So at x equals 0, what does y equal? Well, it's going to be 0, isn't it? Because they're all powers of x, so that'll be 0, 0, and 0, which makes 0. Okay then, there's our 3 turning points. We need the second derivative. We've got dy dx here. So that's going to be a bit of a pain, isn't it? So let's just write down the second derivative here, shall we? d2y by dx squared. Let's see what we've got. Let's try and make life a bit easy. Minus 24x squared. Minus 18x. Yeah? Plus 10. So the first thing to say was when x is 0. So when x equals 0, 0, 0 plus 10 is positive. So min. So we know it's a min at 0. Okay, it's a cubic equation, so we could actually just deduce things. So let's try and just use powers of deduction, hopefully, on this sketch. So let's do the sketch then. So remember our turning points, it's 0.69 and 0.94 is the y. That's the first one. So let's draw our sketch. We'll come back to those values now. Here's our x, here's our y, here's 0. We said that 0, 0 was a turning point. I remember that one. Yeah? 0, 0 turning point. The next one was 0.69, 0.94. So back here, 0.69, put it here. And 0.94 was the output. So that's there. Now let's go back. And we said that this 0 one was a min. So back to our sketch. And we know this one's a min. There's a cubic curve, so it's going to be reasonably well behaved. So, what's the other turning point? Minus 1.81 and 12.7. Minus 1.81. Minus 1.81. And what was the y value? 12.7. Oh, crumbs. It's quite high up, isn't it? So 12.7, which is way up here somewhere. And that's 12.7, yeah? Okay, so because it's a cubic, because that's a minimum and it's a continuous curve, it's got no choice, but it's got to turn here. So if it's coming up from here on the minimum, it's got to be a maximum. And then by the same token, this has got to also be a maximum. So can you see what happens? It comes up, it turns, and there. So basically, by simple deductive processes, rather than spend too long on this problem, I thought we could just do that there. And there's the curve. Yeah, I don't want to spend too long on it. But that's the curve. Okay, let's just check it out in our Wolfram thing. Not Wolfram, our curve plotter. So let's just type it in. That'll take 5 minutes, won't it, to type this thing in. Let's have a go at that then. It's minus 2 times x to the 4. Minus 3 times x cubed. Let's just get that. X power 3 plus 5x squared. Plus 5 times x power squared. Okay, there we go. That's exactly what we had, wasn't it? Well, I mean, you know, it shot up to 12, came down to minimum here, maximum here at 0.69, and then went down, shot down there, shot down there. That's what we had. Good. Okay, that's 12 done then. Horrible question, as we wondered at the beginning, and it confirmed it was. Okay, but that's 12 done. Let's go on to the next one. Hopefully it won't be so bad.